So for today, we will mainly talk about the indexing for vectors in R, and then I will move to matrix. And please keep in mind that there are several ways that we can do indexing in R, or just choose some set elements in R. One of them is just indexing for your vectors, or later we will index for matrix in here. What I mean with indexing is that you are just trying to find the place of the elements in a vector in here, okay, within a vector. And we are just looking for the position of a value within a vector. And here are the rules. Please use square brackets, this guy in here, okay, to select vector elements by their position. And we can use negative index to exclude elements. It's literally negative sign in there. And we can use a vector of indexes if you want to select more than one values. And we can also use logical vector to select elements based on a condition in here. And also there's one way that we can use names to access the names of the elements, okay? Here are the main rules to index your vectors. This topic is kind of important or crucial for starting programming in R. And also I will give examples for each of them in R in here. So let me just share my R screen with you guys. There we go. Where is that one? Here is my R Studio. As usual, I will go to File, New File, and open an R script. Okay. And let me give a title, Indexing in Vectors. And then we will save it into desktop as Victory. Here is what. And now, first of all, let me just generate vector for you guys, like fib vector. And it consists of the Fibonacci numbers in here. And I can always use combine, C command in here to generate a vector. 1, 1, 2, 3, 5, 8, 13, 21, and 34 as usual. And here is my fib vector. And I want to just see the length of the vector, first of all, and how many elements I have in there. The length is 9 in here. Let's say you want to choose or select the first element for fib, okay? So I can just write the name of the vector and use this square brackets in here. And let's say I want to get the first one, okay? Then when you just enter it, you will see that it is giving you the first element of your fib vector in here. Of course, you can always change that number. If I say the fifth one, and then you see that it's giving me the fifth one. Or I can just say the seventh, and the seventh element is the 13 for my fib vector in here. This is how I can easily select my elements in here by using curly brackets. And so please notice that in R, the first element has an index of 1, okay? If you say 1, it's going to give you the first element. It is not 0, as in some other programming languages, such as Python in there, okay? After that one, we can just select multiple elements at once, okay? I'm going to try to select multiple elements. Let's see, here is my vector. I want to just choose the first, like from 1 to 5th, like 1 to 5th, first 5 elements in here. And that's, I guess, easy. Also, you don't have to start with 1. You can just go and say 3 to 6 in here. And here is my 3 to 6 elements for my vector. And also, we are able to select the elements anywhere within the data vector in here. Let's say you want to select the second one, the fifth one, and the seventh one. I'm just going to choose we can just use combine, and I'm going to just choose the second one, fifth one, and the seventh one in my fifth vector. Okay. And now we are going to just move to negative index in here. If we use just a negative index in here, we exclude a value. For example, let's see, I want to just get rid of the first one. And if I say fifth minus 1, it's giving me all the elements of my fifth vector except the first one. Okay, I'm just excluding that guy. Also, I can exclude several of them at once by using combine again, or even I can use some sequence in here. Let's say I want to exclude the second to fifth one. It is my first fifth in here, and I'm just excluding these numbers between 1 and 8 in this example. Okay. Now we will use another way of indexing, and we will use logical vector to select some elements. Let's see, I want to again use my fifth vector in here. Here is my fifth guy. Okie dokie. And I want to choose the elements which are smaller than 10. Let's say I'm looking for this one. Fifth is smaller than 10. You see that the answer is like logical vectors with trues and false. You can recognize that these three guys are greater than 10, and my last three answers are false. Okay, then the rest of them are true because they are smaller than 10. So if you want to select the elements in here, you again need to use indexing. Indexing means we are just adding square brackets next to my vector and just adding the condition. Here is my condition in here, and it is giving me the corresponding elements of truths in here. Okay, this is how we can choose some elements by using our logical vectors. And also you can overwrite some elements in your vector. Let's say I have my fifth 2 in here. You see that here is my fifth 2. We just generated by excluding last to the second element of fifth. And let's say I want to change some elements in my fifth 2. For example, the second one. I want to choose that one as 100. Okay. When I overwrite this one, you see that now my second element is 100. And I can easily change that numbers in there. Okay. And it is not that limited in there. We can even use several elements in here. Let's say I want to use from 1 to 4. We will choose the first elements in fifth 2. And in here, I want to change that to 2, 4, 6, and 8. This is just arbitrary numbers. You can just change them, the ones that you want. And you see that my fifth 2 is now with different numbers for these 4 guys in here. We change them by using indexing in here. Okay. And you can also select some even elements in your fifth 2. Let's say if your fifth 2 is just, okay. When you divide it to 2, the answer is 0. And you see that these are true. That means they are even elements. This guy, also this guy, and you have 2 falses, and these are odd numbers in your vector in here. Okay, you can select in this way. And also there are several ways that we can select all elements that are neither NA nor null in here. Okay, and let's say I want to generate a new vector. Continue. So I'm going to generate a new vector now. The name is V. Okie dokie. Now let's combine some numbers. I'm going from 10 to 1, and let's add 5, and let's add NA. I have some NAs in my vector. That's possible. 2.2 and 3.5, okay? Here is my V vector. I have some numbers, and also I have an NA in here, not available. So I just want to get rid of this guy inside of my vector, and I can just use indexing in here. If I say V, and if I add like is.NA, is there any NA values are in my V vector? Here is how. And I want to get rid of this guy, and you can just add this guy in here. If you want to just get rid of that, you can just add this sign, just the beginning of your code, and it's going to get rid of this NA value for you. Sorry guys, I have to just run this part. Now you don't have any NA values, okay? So now we are going to move to select some elements by name. For that one, I want to generate some vector, a new one. Let's say this is my vector with years. I have my years. I'm going to combine some years, 1923, 1989, 39, sorry guys, 1950, and 1966. This is my years vector. And I want to give some names to my years vector in here. Here are the names. I want to combine some of them. The first one is, oh, sorry guys. The first one is Mustafa Kemal Atatürk. And the second one is İsmet İnönü. And the third one is Celal Bayar. And the fourth one is Cemal Gürsel. Okay. Names and the years. And when I just write my years vector, you will see that I have all my values and all of them has one name in there, okay? And now we are able to refer to individual elements by name after we define the names in there. Let's say I want to choose the Mustafa Kemal Atatürk in my vector, and I just want to see the year in there. Here is my name of my vector, and I want to choose one of the elements. Again, I use square brackets, and then we have Mustafa Kemal Atatürk in here. Then it's just giving me that elements. And also you can combine this part. Let me combine it. I can just add C and add, let's say, one of them here. And now it's going to give me the two elements in this vector by indexing and by using the names in my vector in here. Now we are going to move to a matrix in R. When you define a matrix with m times n dimension in here, let's see, we have m times n dimensions, and that means we have m rows and n columns. And let's define a matrix in R, and I will give it a name as M. Here is my name of the matrix, and we can use matrix comment in here to generate a matrix in here. Maybe you can see that there's a pop-up when I write matrix, and you see that you should first give the data and number of rows and number of columns in here, okay? Here is how we can define. I want to add the ones with 1 to 3. And when I write M in here, you see that it is just generating a column vector for you guys, okay? And let's say I can just play with my matrix comments. And I want to add from 1 to 3, like 3 numbers in my matrix. And number of row is going to be 1, and number of columns is going to be 3 in here. Now we have a row matrix in here. We can always play with that one. And also you don't need to add these attributes in here, because when you just write without them, R will know where to put them. 1 to 3, and the first one is going to be number of row, and the second one is going to be number of columns. And here is my M matrix in here. And if I ask for the class of M, you see that it's a matrix, and it writes at array because it's one-dimensional array too. And if you just say type of my M, you see that that's an integer. Okay, because the elements inside my matrix is integer in here. So class just show, this class command just shows that M is a matrix, and this type of just shows that fundamentally the matrix is an integer vector in here. Okay, and in R there are always different ways to generate matrix. Okay, it's not just using the matrix command in here. You can use some other ways. Let's say I want to generate a vector first from 1 to 20. And if I say the dimension of my M is going to be 4 and 5, that means 4 rows and 5 columns. And my M is going to be a matrix again. Okay, it's another way to generate a matrix, and it's also easy, I guess. And there's one way that we can bind our columns or rows. Okay, to practice this one, first generate 2 vectors. The first one is A by combining from 1 to 5 numbers, and the second one is B. Again, I'm getting from 11 to 15. Okay. I have now A and B vectors. If you write rbind, here is my brand new function. If you write rbind A and B, you will see that it is just binding your 2 vectors by rows in there. Okay, and here is my first one, here is my second one. This is just generating a matrix by binding my 2 vectors in here, and it's really useful, guys. Okay, and also there's a sister of this rbind, which is cbind. Here is my cbind. I have my A vector and B vector, and when I just bind them, you will see that it is binding by columns and just generating a new matrix. And you can use both rbind and cbind by adding a vector to a matrix too, not just combining 2 vectors, but you can also add some vectors to your matrix in here. And let's say I want to generate a new matrix for myself by using rbind A and B. And if I ask for the class of my M1, you see that it is also a matrix in here. And we can just move to another example now. I want to generate a new vector with characters. Let's say I'm combining A and B and C in here, and D and E. Here is my D vector. Now I can just generate another matrix by R-binding, okay? I R-bind my A, B, and now I have D. And when I just write, sorry, I have my A again. I change it to 1 to 4. And you see that when I combine them, if I have one of my vectors as characters, R is converting all of them to one of them, okay? It is not okay for R that's different type of vectors at the same matrix. Please keep in mind that tend to fill a matrix in a column by column direction, and it is just changing all of them in one type. Let's say the class of my M2 is matrix, but when I ask for the type of, you see that it is not a number anymore. It's the character. Please keep in mind that. So let's see that if I write a matrix, I'm writing from 1 to 6. And my number of rows are 2, and my number of columns are 3. And here is my matrix. Maybe you see that R is just filling my matrix in column by column. First writing 1, 2, 3, 4, 5, 6 in here. Okay. So if you want to change this one, if you want to write the direction of filling your matrix, I want to change the direction. Let's say I'm writing matrix 1 to 6. And this time, again, my number of rows are 2. They are same like before. And my number of columns are 3. And if I say by row equals true, this is false in default, okay? But if I change that one as true, you will see that now R is changing the direction, the filling of the direction. And now 1, 2, 3, and 4, 5, 6 by row, okay? It was by column before, 1, 2, 3, 4, 5, 6. It is easy to change. And let's see, I had my M matrix. And if you want to see the dimensions of a matrix, you can just say dim M. And now it's giving you 4, 5. That means you have 4 rows, as in here, and 5 columns, as in here, for your M matrix. Now we are going to subset a matrix in R. Actually, it is very similar to the one that we subset a vector. But this time, please keep in mind that we have 2 dimensions. In vectors, we only have length. But in a matrix, we have class. I mean, we have dimension, and we have 2 dimensions in there in here. So R is asking for both positions, which are rows and columns, for subsetting a matrix. Let's see what I mean. I have my A matrix. I'm going to generate my matrix by using some numbers from, let's say, 0.5 to 8.5. What did I do? 8.5. Okie dokie. And the dimension is 3, 3. And when I write A, you see that I have 3 by 3 dimensional matrix in here. Okay. And now we want to get the second row of A from the third column. Okay. Let's see what we are looking for. Sorry, guys, let me write it here. We want to get the second row of A from the third column. Here is what we are asking for. And now we will get the second row of A from the third column. Again, we are using square brackets in here. I have 2 and 3. The first one before the comma is for 2, and the second one is for row. Second one is for column. And now we have this guy, the third column and the second row in here. Okay. And also you can get only the second row for A if you just write 2 and just leave the column part as blank. And you will see that we are getting the first row in A, or you can just get the first column. You only have this first column in A by writing A, comma 1. And let's say we want to get the first and the third columns in A, okay? Here is what. So now we are trying to find the first and the third columns. Please remember the combined comment we are using as C. And let's say I'm going to use my A matrix. I want to index it by using square brackets. I'm looking for columns. That means my rows is going to be blank. This part is blank. And I'm just getting the columns. I use combine and just get the first and the third one. That's it. Okay. Now I have my first and third columns from here. Or there is one way that some of the guys just use. You can delete the second column in there and you get the same results. Okay. And we can also delete the second row in A by writing -2 and comma and the blank. And also we can delete the first row and the second column. Let's see what I mean. I'm indexing my A -1, -2. Here is how. Okay. Also, you can just replace some values in your elements in your A. Okay. Let's say here is my A. Sorry, guys. It's final. And if you write A, that's different. Okay. R is case sensitive. My matrix is capital A. And if you want to replace some value, let's say the second row and the second column for A, I want to replace second row and second column. Let's say I want to change it to 0. And when you write A, you see that now you have different A. This guy is different because you change it to 0 in here. Also, you can replace all your diagonal elements in this matrix. Let's say I'm writing diagonal. And now if I choose diagonals of all my values, you see these are my diagonals of my A. I can just change them to 1. Okay. And when you write your A now, you have a different matrix. All your diagonal elements are 1 in this matrix now. You can easily change the diagonal elements in there. Let me just move to matrix operations for you guys. We have our A matrix now, and I think we kind of changed some parts in there. Here is my A matrix. And now I want to get the transpose of my A in this example. Here is the transpose of my A. You see that? Now I have the transpose, and you can generate some identity matrix. Let's say if I say A equals diagonal 3, and it's giving me a matrix as diagonals, or I think I should give it another name. Let's say B. I'm generating a new matrix, and now this is an identity matrix 3 by 3 in here. Okay, and we can do some matrix addition and subtraction in here. Let's see what I mean. A, and here is my matrix. Here is my matrix. I want to generate an arbitrary one by adding some numbers. 1, 3, 6, 2, and 3, 5. And let's give the dimension 3 and 2. And here is my A. I'm generating a 3 by 2 matrix. And B is another one. You can just give it any name like potatoes or pizza. And let's say I have 3 minus 2 and 8 and 1, 4 and 5. And this is 3 by 2 again. Here is my B matrix. Okay. I'm generating 2 matrices now. And you can easily do some addition for your matrix by using A plus B. Okay. And here is how I am doing addition. And you can easily make some subtraction for your matrix, A minus B. Here is my A minus B. That's also easy. And for matrix multiplication in here, guys, please be careful with the dimensions in here, okay? Remember that the dimensions should be the row of the your first matrix in here, okay, and the number of the rows and the number of the columns for your second matrix should be the same in this example. Let's say I have the dimension of A, it is 3 by 2, and I have the dimension of B, it is 3 by 2. Do you think it is possible to do matrix multiplication in here? So they are not same in here. The column and rows has to be same for matrix multiplication in here, guys. What can we do? We can overwrite B by getting the transpose of my matrix in here. Here is the transpose of B. You see that when you just check out for the dimension of B this time, it is 2 by 3. Let's see. The dimension of A is 3 by 2. The dimension of B is 2 by 3. That's okay now. Now we confirm that the two matrices are compatible for multiplication in here. Okay, let's see. Yeah. So if you want to do that, there is one sign, a special sign in here for matrix formats, which is this one. For matrix multiplication, guys, you have to use this sign, okay? This is how R is doing that job for you. Yeah, this one. Okay, okay. And if you want to get the inverse of a matrix, there's something in here too. Let's generate another matrix for us. And here is my A matrix. I want to generate it by using rbind. And the first one is 3 and 1. And the second vector for me is 4 and 2. And if I write my A, I have 3, 4, 1, 2. It's an easy one. And if you want to get an inverse of a matrix in here, you can just use solve A, okay? And then R is just giving you the inverse of that matrix. And you can even check how is it working. If you please remember that if I get A and A transpose, what would I get in here? If we have A times inverse A, we are just getting identity matrix in here, okay? And actually, this is all I wanted to say about indexing vectors and metrics and some indexing for our matrices in here. Also, we covered some matrix operations together and we subset some matrix, and now we have some basic information about matrix operations in R.